So one last thing I wanted to mention for everyone out there. As I was doing this and we're CCing this head, I have set up here on the table to my milling machine. We can just set this head down here. And so the head is now, assuming the head's flat and not warped, it's resting on this table. And this is table 2. This is, kind of precision equipment here. So what I'm going to do is I am going to going to demonstrate something. Here's what I'm trying to demonstrate before I do it. That the top part of these 3 surfaces here is parallel to the cut on the cylinder head here. So in other words, when I set this down on the milling machine on its table, this dial indicator, if it remains a constant from this point as we move across to this point, and that tells us that this surface and this surface here are parallel. So we're going to do that now. I'm going to set this in here, and I am going to move the table so I think hopefully you can see, and there's not too much glare on the dial indicator's lens. There we go. And we got that at 0, and then I'm just simply going to walk us across, and we see, and mind you that this is reading in 1/2 thousandths of a scale. So each graduation on this is 0.5 of thousandths, so 0.0005. So as we move across there, we come off that, and we move over to here, and there we are again. I'm going to jump right off that little feature there and then back on again. So what you could see is that this surface and this surface make a parallel plane. It's parallel to this table. So for those of you who are so inclined and want to, for milling heads, you can make yourself a fixture that's super simple. Just a block of aluminum machined on both sides, hole pattern to match the head, and then we can bolt this guy down. And I got it upside down. As you can see there are the witness marks from the heads of the bolt, because that pattern is not symmetrical. We can bolt this guy down. And then we can fixture this into a vise that would typically go on the table of a milling machine with a set of parallels, and then that gives us the ability to machine the surface of the head and change the compression ratio of the engine, and effectively reducing the volume of this cylinder head. I know from experience, as I've already cut one of these, I have a second head that's on an engine, that it takes about 6 thousandths of a cut on this whole surface yields 1 cc drop in cylinder head volume. So, and that'll hold true until we lose this ridge, and then at that point you get into a cone shape and no longer a cylindrical shape. So that's just in the process of CCing heads and screwing around with this, just something I observed. A lot of you guys probably already know this, or claim to have known this, or tell me that I should just throw this in a dumpster and get an AD head, but whatever. Just pointing out some facts that I can show here and document.